Here is the strangest thing happening in AI right now. You can take the smartest model on earth, give it more information, more context, more documents, and it gets worse, slower, more confused. It starts forgetting things you told it 10 seconds ago. Researchers have a name for this. They call it context rot, and almost nobody building with AI understands it yet. Because the real skill of 2026 was never about writing a clever prompt. It is about engineering everything the model sees before it ever answers. This is context engineering, and by the end of this video, you will understand it better than 99% of people using AI today. Let me show you the machine. For 2 years, everyone obsessed over prompt engineering, the perfect wording, the magic phrase. Then in June of 2025, the whole field quietly renamed itself. It started with Toby Lütke, the CEO of Shopify, who said he liked the term context engineering because it described the real skill better, the art of providing all the context for the task to be plausibly solvable. 6 days later, Lütke Karpathy, founding member of OpenAI, amplified it. He called context engineering the delicate art and science of filling the context window with just the right information for the next step. Then Simon Willison said the term would stick, because unlike prompt engineering, this one actually means what it sounds like. To be clear, the idea is older than the label. But June 2025 is when it broke into the mainstream. And the reason it stuck is simple. It named the work that every serious AI engineer was already doing. So here is the mental model that makes all of this click. Karpathy describes a large language model like a kind of computer. The model itself is the processor, the CPU. And the context window, everything you feed it right now, that is the RAM, the working memory. And just like the RAM in your laptop, it is finite. Anthropic puts it precisely. They say context must be treated as a finite resource with diminishing marginal returns. Every model has what they call an attention budget, and every single token you add spends a little more of it. So the goal is not to cram the window full. The goal, in Anthropic's own words, is to find the smallest possible set of high signal tokens that maximize the chance of a good answer. Signal, not volume. Hold on to that idea because it is the secret behind every technique that follows. Once you see context as a finite machine, your job becomes managing what goes in and what comes out. And the team at LangChain organized this beautifully into 4 levers. Right. Saving information outside the context window so the model can come back to it later. Select. Pulling the right information into the window at the right moment. Compress. Keeping only the tokens you actually need. And isolate. Splitting context across separate agents so each one stays clean. Write, select, compress, isolate. Every advanced trick you have heard of, memory, subagents, retrieval, compaction, is just one of these 4 levers. So let us pull each one and watch what it does to the machine. Lever 1, compress. Picture a long conversation with an AI agent. It is doing real work, calling tools, reading files, and the context window is filling up fast. What happens when it gets near the top? This is where compaction comes in. Anthropic describes it as taking a conversation that is near the limit, summarizing it, and starting fresh with that summary. If you have used Claude Code, you have seen this live. Around 95% full, it auto-compacts, preserving the architectural decisions and unresolved bugs while throwing away the redundant tool output. But here is the part most people miss. The single biggest source of wasted context is old tool results. In one of Anthropic's own demos, simply clearing stale tool calls dropped the peak context from 335,000 tokens to 173,000. That is a 49% cut from one setting. Compression is not about losing information. It is about keeping the signal and dumping the noise. Lever 2, isolate. This one is the most powerful and the most misunderstood. The idea, instead of stuffing everything into one giant context window, you split the work across multiple agents, and each sub-agent gets its own clean window. One researches, one writes code, one checks the result, and none of them pollute each other's context. Anthropic built exactly this for their research system. A lead agent delegates to sub agents running in parallel, each one exploring with tens of thousands of tokens, then returning only a tight, distilled summary. On their internal research eval, that multi agent setup beat a single agent by 90.2%. But there is a real debate here, and you should know both sides. The team at Cognition, who built Devin, push back hard. They argue that when agents cannot see each other's context, their decisions silently conflict, and the work falls apart. So here is the honest rule. When the work is independent and rate heavy like research or search, parallel subagents win. When the work shares state and writes into one artifact, like a single code base, keep it on one thread. Isolation is a scalpel, not hammer. Lever 3. Write. Here is the problem. Isolation cannot solve. When the context window resets, the agent forgets everything. The fix is to give it memory outside the window. Anthropic calls this structured note taking. The agent writes notes to a file, a scratchpad, or to-do list and reads them back later. They tested this with a Claude agent playing Pokemon. After its context was wiped, it read its own notes and just kept going. Continuing training sequences, it started hours earlier. You already use a simple version of this. In Claude Code, it is the CLAUDE.md file. Persistent memory. The agent reads every session. The team behind Manus took it further and treats the entire file system as context, unlimited, persistent, and operable by the agent itself. And there is a clever trick called recitation. By rewriting its to-do list at the bottom of the context, the agent keeps its goals fresh in attention, instead of forgetting them halfway through. Write things down. It is what humans do. And now, it is what agents do too. Lever 4. Select. Out of millions of possible tokens, which ones actually make it into the window? For years, the default answer was RAG, Retrieval Augmented Generation. Embed all your documents and pull in the closest matches. It works, but in 2026, it is being challenged. The newer approach is just-in-time retrieval. Instead of pre-loading everything, the agent keeps lightweight references, file paths, links, queries, and loads the real data only when it needs it. Anthropic points out this mirrors how humans actually think. We do not memorize the whole library. We remember where to look. The honest take? RAG is not dead. The state of the art in 2026 is a hybrid. Use retrieval to find the right material, then give the model room to reason over it. Selection is about precision, getting the right thing at the right time and nothing else. Now for the part that separates people who get this from people who do not. The science of why context breaks. Drew Brunig mapped out 4 ways a long context fails, and once you see them, you cannot unsee them. 1. Poisoning. A hallucination sneaks into the context and gets referenced again and again. 2. Distraction. The context grows so long, the model fixates on it and forgets what it learned in training. 3. Confusion. Irrelevant junk in the window drags the quality down. 4. Clash. New information contradicts something already in the context and the model breaks. And this is backed by hard research. A Stanford study called Lost in the Middle found that models reliably use information at the start and the end of a long context, but lose track of whatever sits in the middle. Then there is the benchmark that should scare every builder. It is called no-lemma. When they tested top models on genuine reasoning across long context, GPT-4o dropped from 99% accuracy at short length to under 70% at 32,000 tokens. 11 of 13 models fell below half their score. The lesson is brutal and important. The context length a model advertises is not the context length it can actually think across. Here is the one almost no tutorial covers, and it is where the real professionals live, the KV cache. When you reuse the exact same beginning of a prompt, the model can cache that work instead of recomputing it. and the savings are enormous. The team at Manus found cash tokens cost 10 times less than fresh ones, 30 cents versus $3 per million on Claude. They call the cash hit rate the single most important metric for a production agent. Why? Because agents are read heavy. Their input to output ratio is roughly 100 to 1. So the rule is keep the start of your context stable. One tiny change at the top, even a timestamp, invalidates everything after it, and your cost explodes. Context engineering is not just about quality. At scale, it is about money. Now, let me be honest about the limits, because hype helps nobody. First, cost. Attention scales quadratically. Roughly, double the context and you quadruple the compute. Bigger is not free, and it is not always better. Second, the skeptics. Some argue context engineering is just prompt engineering with a fancier name. There is a grain of truth, but the better framing is this: it named work that was already happening and gave it a discipline. And third, the hardest one. Even with perfect context, agents still fail because errors compound. If every step is 95% reliable, a 100-step task succeeds less than 1% of the time. That is not a context problem. That is a reliability problem. And it is why agents that run for hours are still genuinely hard. Context engineering is the most important lever you have. It is just not a magic wand. So, where are we now in 2026? Context windows have exploded. Claude, GPT, and Gemini now all reach around 1 million tokens. Meta's Llama 4 Scout claims 10 million, and Magic.dev demoed 100 million token window. But remember the lesson: advertised is not effective. That is exactly why context management became a first class feature. Models now ship with memory tools that persist across sessions, automatic context editing that clears stale data, and live token budgets the model can actually see. In Anthropic's testing, those memory features lifted performance by 39%. The window got bigger, but the skill that matters did not change. Curating what goes in is still the whole game. So if you remember one thing from this entire video, make it this: prompt engineering was about typing the right question. Context engineering is about engineering the entire world the model wakes up into. That is not a wrapper. That is the job. And every technique we covered, compress, isolate, write, select, all of it serves one principle: find the smallest set of high signal tokens that get the work done. Master that, and you are ahead of almost everyone in this field. Now, if this gave you value, do two things. Subscribe here on YouTube and follow Hyperautomation Labs on Instagram and Facebook, because this is exactly what we go deep on every week. And I packaged everything in this video: the 4 levers, the failure modes, the checklists, into a free context engineering field guide. Just comment the word signal and I will send it straight to you. If you want to go further, the beginner Claude code guides in the description take you from zero to building real agentic systems. Now go engineer your context.